It's Miss Dreyhaus here, and I'm really excited to share with you this very first lesson about the abiotic factors in this hydrothermal vent ecosystem. With that being said, I'm going to use this video to go through the guided notes and the PowerPoint, and I'm going to give you all of the answers. Everybody's favorite. With that being said, I want to show you how to get to the questions. You click this link, it gets you to this questions. You click this PowerPoint link or this PowerPoint link, and it gets you to this PowerPoint. Okay, so with that being said, let's get to it. So every slide, except for the title slide and the closing slide, have exactly one question that goes with it. So this slide has no question, but the very next slide, this one, does. Haha. Now, this slide has a lot of questions on it, a lot of questions you guys wrote. How did the vents form? How did the creatures adapt to extremes? All of that jazz. Yeah, so if one of these questions was yours, or if you wrote a question about possibly the abiotic or geological factors, back when we did the thing where you did the research and then you asked a question or an interest or whatever the third thing was, if yes, you're going to, go with yes. Yes, you did. And if yes, your question or interest was, well, I did. I had a question or interest. I wanted to know how hot the vents got. So write your question there that you had, or if you didn't have one, just, delete this. But I had a question. And then that's what you write down for this first slide. You can also check out some other people's questions. I want to do a slide like this for every one of my lessons. And when I build a lesson, I actually build it to try to get your interest, to try to gauge what you'd like to know. So yeah, ask good questions. If you want to go back and edit it, do that. So yeah, let's go on to the next question and the next slide. So question 2. So question 2 is interesting. It's another different sort of a question. What is your favorite part of the visuals shown here on slide 3? And how might you be able to include that element in your final model? So I'm giving you some pictures of models of hydrothermal vents. And these just show the abiotic factors. There's no organisms really doing anything here. It just is a diagram showing how the abiotic factors work. And I would recommend you showing abiotic factors or planning to show abiotic factors in your final model. So think about your favorite one. Look at these pictures and what makes a lot of sense to you. What seems super cool? What would you really like to show? Well, I like how the layers are shown here. And I think that's pretty neat. And let's say my final model I'm planning on doing is drawing a picture. You don't have to draw a picture. You can do a PowerPoint or whatever. Like you could do PowerPoints with different slides, with different layers, whatever. Anything. Or just the difference between the two smokers. Just take a good look at these, and it might make more sense later. But yeah, so I think my favorite part was, let's go with the temperatures. That's a good part because my question was about the temperatures. So the temperatures written in the vents. So looks like here it's 2 degrees Celsius. There it's like negative. It's like 2 degrees Celsius as well. And then here it's like 350 degrees Celsius. Wow. So really hot to really cold really fast. So I could just write those degrees in. So something simple like that. And then do it in your final model if you have a plan, or you don't have to do it anyway. Let's go on to question 3 in the third slide. How are the chimney-like vent structures formed? So let's go over here. And it says, well, how are the hydrothermal vents formed? So I guess this should tell me a bit about that. This is some really neat text that says some fancy things. And what it says is really hot, really rich vent juice leaves these vents from the earth. And as soon as it hits that cold water, it kind of drops off. It's particles making the juice super dense, and those particles become the chimneys. And this is a super awesome video, a piece of it showing that happening. And I'm going to play it for you. So enjoy this video of a video of a video.
The structures came to be known as hydrothermal vents for the superheated water they emit. Hydro, meaning water, thermal, referring to temperature, and vent, indicating the release of matter.
And the sound will be way better if you watch
Along
this on
volcanically active areas such as the mid-ocean ridge, water seeps into the Earth's crust through cracks and fissures and becomes superheated by hot magma within the Earth's layers. As it boils up to be released on the ocean floor, the water picks up dissolved metals and minerals along its journey. And finally, the water exits the Earth's oceanic crust, creating vent structures. The characteristics of hydrothermal vents vary depending on the specific metals and minerals in the water they emit. Vents known as black smokers emit water that appears as a thick black cloud because it is rich with sulfur-bearing minerals. As the dissolved minerals and metals encounter the freezing ocean water, they solidify in layers, forming massive structures called chimneys. Lasers, spaced at about 10 centimeters apart, almost 4 inches, help scientists determine chimney size. Some chimneys have been spotted at heights of up to 18 stories tall. In contrast, white smokers are characterized by the barium, calcium, and silicon they contain. Some vent fluids aren't characterized by a specific color, but can be identified by the shimmering water they emit due to the stark difference of water temperatures. And other vents simply emit carbon dioxide in streams of bubbles like carbonated soft drinks. Don't be fooled by what may seem like gently flowing water. The water pressure is so great down here that what appears to be a gentle outpouring of water would actually be a violent eruption if it were on the surface, much like geysers we see on land. The vent fluid can be up to 750 degrees Fahrenheit, 400 degrees Celsius, but it does not boil because of the immense pressure. It's amazing that life can thrive under these conditions, in the midst of scalding hot water, immense pressure, and near freezing ocean depths.
So yeah, that is the little video I wanted to show you.
The structures
the
came
next
to be known
question.
as hydrothermal vents for the superheated water.
Be quiet. So the next thing I want to show you, and the last question we will be getting to in this video, is asking about what makes a white smoker and a black smoker, black and a white smoker. So the next slide kind of breaks down some of the things the video also said. And it says black smokers are the chimneys formed by deposits of iron sulfide. Think like a black cast iron pan. Iron sulfide is what's being dropped out and stacked on top of itself, and building up these black smokers. And white smokers are formed by barium and calcium and silicon. And think like sand. Sand is mostly silicon, and sand is white. Calcium, bones. Bones are also white. The reasoning behind this is super simplified and not accurate, but if you can remember black, like a black cast iron pan, iron sulfide is the black smokers, and white, like silicon and calcium, or white like bone, are the white smokers. Calcium, bone, white smokers. So black smokers are black because of iron sulfide. White smokers are white because of barium, calcium, and silicon. Oh, I forgot to mention, vents are formed by minerals being deposited by the vent. Oh, yep. Those are questions 1 through 4. I hope this video makes sense. See you later. I'll see you in the next video.